points reflected about the y-axis look something like this. Let's make an x and a y. So if I have a point over here in quadrant 1 and I call it xy, reflected about the y-axis puts us in quadrant 2, and when it's reflected about the y-axis, the ordered pair becomes negative x, or the opposite of x, comma y. So when we have points that are reflected about the y-axis, we use this notation. xy becomes the opposite of xy. And likewise, when we have a point that is reflected about the x-axis, here's our x-axis. So again, I'm going to start in quadrant 1. That ordered pair is going to be, blue. That ordered pair we'll call xy. When it's reflected about the x-axis, x stays the same, but this time y is going to change its sign. So we write that xy becomes x opposite of y. You might remember this notation from your geometry class. And when we're reflected about the origin, so if I have a point, again, we'll say in quadrant 1, and we'll call it xy again, x comma y. Reflected about the origin is going to put us negative x, negative y. So that distance from the origin is maintained. So we have the opposite of x, opposite of y. So xy becomes the opposite of x and the opposite of y. I'm going to fix that real quick. The opposite of x and the opposite of y. So you can see distance from wherever we're symmetric about is equal. So our distance, those green segments are equal. This distance is going to equal this distance. So that's what happens when you've got symmetry in those particular, about the y-axis, about the x-axis, about the origin. Now, when the first or last happens, the graph is a function because it passes the vertical line test. So here I'll draw a vertical line with my purple pencil here. That's not a good one. That's a fine one right there. So we've got this purple line, and you can see that it doesn't pass through 2 points at the same time. However, once we go to this middle one, reflected about the x-axis, it's going to violate that vertical line test. So whenever you have symmetry about the x-axis, you're not dealing with a function. So this is not a function. Something interesting to keep in mind. When you have symmetry about the y-axis, it's actually not just a function, but we call it an even function. So it's called an even function. And when you have symmetry about the origin, it's also going to be a function, but we call this one an odd function. And there's kind of a reason for that. I'll go into it in some examples. But let's just practice here. Let's reflect the point 4, -9 about the x-axis. If I reflected about the x-axis, I need to follow this rule. So my ordered pair, 4, -9, is going to become, well, x's stay the same, and the y's change their sign. So that's going to become 4, +9. And about the y-axis, 4, -9, so this is our answer right here. Sorry about that. Reflect the point 4, -9 about the y-axis. Well, what happens? Y stays the same, but x changes its sign. So that's -4, -9. And reflected about the origin, both coordinates change their sign. So we'll have -4 and +9. And you can draw a picture of each one of these to confirm visually. If you're a visual type of person, you can confirm visually. Now, equations and symmetry. So we're going to determine if an equation has symmetry about the y-axis. And how you do that is you put negative x, so you put the opposite of x in for x. And if you get the same equation, then you have symmetry about the y-axis, which we call an even function. This is what it looks like in function notation. You put a negative x in, and you end up with the f of x that you started with. So when f of negative x equals f of x, you're going to have symmetry about the y-axis, and we're going to call that an even function. Let's take a creative color here, because that's pretty important right there. Now I want to stay with functions, so I'm going to hop over to the origin. So when we have symmetry about the origin, we find out by putting a negative x and a negative y in. So you can hopefully tell here, see, we're putting a negative x in for the reflect about the y-axis, and the y's should stay the same. So you put a negative x in, and you should end up with the y equals that you started with, or the f of x equals that you started with. Here with the odd function, or with symmetry about the origin, which is synonymous, you have to change the sign of both negative x and y to be negative x and negative y. So you put negative x and negative y in for x and y. And if you get the same equation, then you have symmetry about the origin. Now, you could also put a negative x in. I'm going to show you right here. You can put a negative x in just for the x value. So you put a negative x in everywhere you see an x, and if you end up with the opposite of f of x, so you end up with a negative y. This is like the same thing, negative y. So you put a negative x in and you get negative y out. Look at this. Negative x in, negative y out. It's a beautiful thing. Then you are going to end up having an odd function. I want to delete those arrows because I need to write here, odd. And again, this is pretty important, so we're going to make this bubbled. Those are really important concepts in algebra. And if you remember them, you know, like anything else, when you remember these little things, it can make some algebraic procedures a little bit easier when you remember them. Sadly, we don't always use them, so we don't remember that it's available to us. Put negative y in. So now about the x-axis, this is not a function. So I can't use any function notation. I can't say f of x equals, because if it's symmetric about the x-axis, look, it's something like this. It's something that's going to fail the vertical line test. It's not going to be a function. So you put a negative y in for y. And if you get the same equation, after simplifying, of course, if you get the same equation, then you have symmetry about the x-axis. This is not a function. So where are you going to see this happen? Well, the equations that we're going to become familiar with in this course are circles, and I'm going to show you at the end of this series of videos, we're going to actually work with circle equations. Circles, ellipses, parabolas, those are all symmetrical about the x-axis. So parabolas that open left to right. And those are conic sections. All three of these are in conic sections. These are non-functions because they all fail the vertical line test.